Okay. So in a couple seconds, we should see. Okay. Yeah, a little less cool, but okay. So yeah, so okay, we're back. I apologize for that little hiccup there, but yeah, like I was saying before, I've got OpenSCAD set up here. I prefer editing in VS Code. So if some of you were doing the tutorials online and you see screenshots of people editing in the app, that's just not how I like to do it because I like using hotkeys and I have something that can auto format. So you're going to see me switching between VS Code and OpenSCAD. And so yeah, so we were saying before, are we good now? Is everybody good? Okay. So yeah, let's pick it back up. Yeah. Oh, can you leave that there? Actually, that's pretty helpful. Um, so yeah, so there's color, and that's just an example of a simple transformation that you can do. There's tons and tons more transformations that are available, and there's something that I wanted to point out that it's kind of like an alternative syntax. So you see here, there's a translate operation, and then inside the translate operation, there's a color operation, and then you've got a circle there, right? So that's one way to do the syntax, but you can do an equivalent syntax if you go like this. And this is used more when you have like multiple operations where where there's only one thing in the curly braces. In those cases, you can remove the semicolon there and just do it all inline, and it's exactly the same. Does that make sense to everybody? It's just no curly braces, and if I save this and go back to OpenSCAD, you're going to see that the result is exactly the same. So, any questions so far? All right. And Daniel, please feel free to interrupt if anybody comes in on chat. Were you able to share the new link on the Slack channel? Okay, great. All right. Yeah, Paul, if you can just keep an eye on the chat window in case anybody goes in. So okay, so yeah, so there's other solid objects and both 2-dimensional and 3-dimensional that you can do here. So we're taking that color operation that we learned earlier, and we're creating cubes. You're going to notice that if you have a cube that is equal on all sides, you can actually just pass in one length. But if you have a cube that has multiple dimensions, like 8, 16, 24, like a rectangular shape, you can pass that in as a vector. And this is something that we haven't seen in the syntax yet. It looks like an array in most modern languages, Ruby, JavaScript, Python, I believe. They all do arrays with the square brackets. And you're going to see that in a lot of other places too when you do these 3-dimensional type things. And so if we took this and I pasted in over here, you're going to see that, there's an interesting thing too. I forget if anybody knows what causes this. The renderer gets kind of funny when you have two solid objects that are exactly in the same place. It doesn't. It's what?
It's called T fighting.
T fighting. Oh, interesting. Z fighting.
Yeah.
Oh, okay.
So you just have to make that chunk of the thing slightly larger.
Yeah, if you just added like a decimal point to that, you could make that go away. It's not bothering anything here, so I didn't bother with it. But you can see here we've got the square here that's actually 2-dimensional, even though it appears to have a width. It's a 2-dimensional shape, and then equal distant cube, and then lastly the rectangular shape there. So we've got that. So okay. So now these are getting more advanced because it's not enough to just make your design entirely out of just simple shapes. You're going to have to start getting more advanced. And so let's start with something simple here. So I'm going to comment out the top and the bottom. These comments shouldn't look too unfamiliar if you've worked with like JavaScript. So you know by me doing that, that's going to have no effect. And so then what we're going to do is we're going to take a sphere with a radius of 10, and then right next to it, 20 elements over on the x-axis, we're going to have another sphere that's going to be have a radius of 10. And so that's expected, right? But what we're going to do now that we have those two together, is we're basically going to cover them in plastic wrap using something called a hull transformation. And I'm going to delete this one for the sake of simplicity. So yeah, you can see right here, we've got this thing called hull, and it really makes sense when you see it, right? By taking two objects and putting them inside of a hull transformation, it's been wrapped in plastic wrap essentially, and so now these two spheres that were next to each other, it now kind of has this capsule shape to it. Very useful in a lot of different applications. It's generally applicable to a lot of the designs that you might make. And then on the flip side of that, there's a different transformation called a difference, and I'll run the formatter there. So this one, I'm going to show you all of them together later, but the difference is has the same syntax as anything else, and so we're taking a sphere here, and then another sphere that's next to it. So that's how they would look if we weren't applying the translation. But if we apply the difference translation, one of those is going to take a bite out of the other one, and it essentially becomes a whole. Yes?
Two questions. One of them, Inventing 2023, is just a general question. Getting back, is making 3D models with code more practical than making them manually?
That's a great question. And the answer so the question was, is it more practical to make a design with code than it is to do with a more interactive like Tinkercad or something like that? And the answer, unfortunately, is it depends, which I know, Daniel, you like that answer for a lot of questions. But it truly does depend. So if you were making, like we had a guy at the Makerspace who was making something that needed very specific lengths of pipes with specific connectors, and the pipe connectors were almost all the same, but they had like slightly different openings, slightly different inner diameters, slightly different outer diameters. So if you find yourself in a situation where you have those kind of parts, like keys, serial numbers getting etched onto things, then it makes more sense. But if you're like an artist building a sculpture or something like that, I think probably doing it in code is going to get in your way.
So it depends on like if it's a one-off or if it's like many of the same thing but with some permutations.
Exactly. If having parameters makes it more powerful, then it's probably an appropriate use case for OpenSCAD. The other one is like if you're making plates, like metallic plates for machinery, and the whole distance needs to change. But for something like a statue, like an artistic work, I would say it probably doesn't make sense. Although, like we saw, some people still do it. But generally, the power of this comes in the parameters. So great question. Can I get the next question, Paul?
One comment, I'm glad you repeated the question because I'm not sure it's picking up the audio.
Oh, okay. Yep.
And then, what's that? It's not going to pick up the audio. Okay. I'm almost embarrassed that I've never seen a whole function in a CAD program. That's awesome.
Yeah, it's really useful when you have shapes that are basically just wrapping around. You can create like a skeleton for what you're trying to design. What's that? Oh yeah, sorry. The great question, Paul. Yeah, so somebody mentioned that they're surprised they haven't seen the whole transformation, HULL. And yeah, it's totally one of the transformations that you're going to be using a lot. It just has so much general applicability when you want to create like a skeleton and then wrap an outer shell around it. So yeah, any other questions coming in through the chat?
One more comment, I could see it being good for generative models.
Yes, there's a lot of neat things. I've seen people use it for generating random trees if you needed to create a model of a tree and you want the branches to always be different. I've seen somebody do that, and that was a response to the comment about it being useful for generative models. So, yeah, great. Any other ones coming in? All right, good. Love the questions, guys. Thank you. So getting back to what we were working on, you see here, this is called the difference transformation. If you've used Tinkercad, I've heard Tinkercad use the term whole, H-O-L-E, not to be confused with that other term we just learned. And you can think of the difference transformation as basically that. You're taking an object, and instead of making it an object, you transform it into a whole that gets, bitten out of the other object. Also very useful, like if we went back to my first slide where I created a funnel, I took one cone and I subtracted that cone from a larger cone to make a funnel. So that's the difference. So we've covered whole, we've covered difference. Now we're going to get a little bit more interesting here with a transformation called the intersection. And so I'm going to show you, before I show you what the transformation does, I'm going to show you what happens if we don't have the transformation. So I'm going to comment this out. Okay, so we've got that. And then, okay, so it's, again, we're starting again with just two spheres that overlap each other. And now I'm going to uncomment the intersection, and we're going to get a shape that looks like a lens. And by the way, I think I did see some people do some like lens and like reflector type designs in OpenSCAD before. But does that make sense to everybody? You're basically taking two objects, placing them together, and wherever those two objects intersect, that's going to become the new object. And anything that doesn't intersect is going to be removed from that model. So does that make sense to anybody? Any questions so far? All right. And then the last one, the last one, it doesn't have a lot of usefulness with anything we've learned so far, but it's called the union. And what a union does is when you want to take multiple objects and group them together. If you've ever used like Adobe Illustrator or Google Slides, have you like control clicked multiple objects and then you right click and you hit group all? If you're familiar with that, that's kind of what this is. And this is going to be more useful when you get into some more advanced transformations that only accept one object as their input. So this will allow you. Yes, we got a question.
This is a union and not a group, correct?
Yeah, the question was, this is a union, not a group, and that is correct. I'm calling it a group to kind of simplify things, but what's that? There's it does get a little tricky with the wording there, but I'm trying to use more general terms. And just so you know, visually they look the same, but there are some advanced operations that we'll cover later where you have to do this union operation so that they can be considered, one object. So good question there. Any other questions coming in? All right. So these four, you're going to use them nearly all the time. When you're trying to do a 3D print on one of the machines here, or you're even doing a two-dimensional laser cut on the laser cutter we've got upstairs. These are all very general use operations. And going back to that question about is it useful to be using code to make 2D and 3D models? One use case I came up with was if you wanted to make serial number tags on the laser cutter. So I created this two-dimensional design, and I'm going to walk you guys through it one by one. So the first thing we're going to have here is we have a difference operation. So we're taking this thing, and we're going to subtract it from that thing. Okay? So we've got a square. It's just 48 millimeters by 12 millimeters. Okay? And then we're going to take a circle, and we're going to move that circle off into the corner of the square, and that's going to basically be like a hole punch. But then the next thing that's really cool, which would be harder to do in a non-parametric CAD program, is I've got this serial number here. So I'm going to go ahead and save that, and it'll make sense when I show you here. So you can see here I've made a serial number tag, and unlike a non-parametric solution, if I needed to change the serial number, or if I wanted to make a shell script that's going to make 10,000 of these tags, it would be pretty easy to do. And at that point, I could just go over here, File, Export, and I could export a DXF file that we could run on the laser cutter here at the Makerspace. So just be aware of that. There is a 2D subsystem, and I find it incredibly useful. Like I've already mentioned, it does do 2D and 3D. How are we looking on questions? Any messages coming in? All right, great. Okay, so this one I think will help put that question, answer the question very thoroughly. There's a really cool, so in OpenSCAD, if you go to File, then go under Examples, just like with Arduino IDE, if you're familiar with that one, there's a really cool example here called candlestand.cad. So I'm going to click this, and so one of the contributors to OpenSCAD, they made this design, and it's obviously a candle stand. I'm going to remove the show edges so that it looks a little bit better. Which one? Oh, yes. Yeah. So it's under the parametric subcategory there, candle stand. And so this is a newer feature. If you haven't used this program in a couple years, this is something that might surprise you. But the author here, you're going to notice they put a special comment. Can everybody read that okay? Is that coming in? Is that pretty? Okay. So you see that they put the word candle stand there. And I'm going to save this somewhere else just so that I can edit it, because right now it's read only. Okay, so now it's not going to be read only. And you see here on the right side, we have this menu system, and this is not part of the program, right? This is a user-defined menu system. And the way you do it is you can use variables, which we haven't learned about variables yet, but they're pretty unsurprising if you've come from a language like Python or Ruby. Unlike JavaScript, there's no var keyword here. But you can see here, the author of this program, they put in a variable called length, and it has a default value of 50, but they put a special comment under right next to it where it's got this special syntax with the square brackets where it says 70 is large, 50 is medium, 30 is small. And so I can actually, in the menu system now, because they put that special comment there, I can shrink the height of the candle stand. If I want a large candle stand, I can do it there. And so this is not like, they didn't have, some plugin to do this. It's just that because they wrote these special comments in their .scad file, it showed up. And so I can do all kinds of other things. Like I have a slider here where I can change the number of candle holders. If I want to have one that's got just tons of candles on it, all I have to do is slide that. So hopefully that answers the question about, is it worth the trouble, So yeah, any questions so far on that? Yes, Gail.
Just a comment, in OpenSCAD, the equivalent of bringing up that side menu is customizer to view customers, and then see what you're seeing in Visual Studio.
Oh, yes, correct. Oh, all right. Okay, yeah.
I'm not doing, I don't have Visual Studio, I'm doing what you're doing in OpenSCAD.
Okay.
In OpenSCAD.
Yes.
So I'm trying to keep up, and that's how
Okay.
where I'm finding it.
Gotcha. Yeah. So Gail brought up a good point. That the name of this feature with this side panel that you see here, this is called the customizer. So if you want to learn more about it, you're looking in the manual, which is really good, by the way. You'll see it here. There's a chance that your default settings are hiding the customizer. So if you go to the window menu and just make sure that that's unchecked, because it will hide it. So yeah, I could see this super useful for fasteners, plates, anything that has a high amount of configurability. Great question so far. Any others before I move on? All right, let me get a sip of water here. Okay. So yeah, Customizer, really great new feature that they added. There's another thing. You're going to sometimes see these $ variables. I don't know if they're officially called special variables. I call them special variables because these are variables that when you change their value or when you read them, they are actually kind of like almost like a reserved word, but it truly is just a variable. The one that's really important is this $FN. If you're on an old laptop that does not have a good graphics card and you start noticing that your computer slows down when you're doing rendering, one thing you can do is you can go to the top of your sketch and you do $FN and you set it to a really low number like 5. I'm going to do that right there, and then I'm going to re-render it, and you're going to see, okay, no, I guess I went too far on that one. Hold on. It disappeared. Just one moment. It is taking a little bit to render here. Yeah, just one sec. Sorry about that. Let me go to preview mode. I'm going to cancel this render maybe, if it'll let me. Oh, as if we haven't had enough tech issues today. Okay, there we go. So you can see, did you guys notice how before the cylinders were very smooth? And then I changed the $FN value, and it's a little bit blockier. What you probably won't notice from watching on YouTube is that it's much faster. The rendering times have improved significantly, and that's because the number of polygons on this model is decreased. So I don't know. Does anybody know what FN stands for, Timmer?
Not exactly, but you can also do a conditional on preview.
Yes, that's so. Timmer just mentioned that you can actually do a conditional, and the conditional is actually using a variable that we mentioned in the next slide, which is $preview. And so you can use a lower value for preview and a higher value for when you render. So you could do like 10 in preview mode and maybe 50 in regular mode. Is my ternary syntax correct? I haven't used a ternary in OpenSCAD in a while. Okay, so we're going to do that. And so, yeah, so and just a note, if you're coming from a language like Python that doesn't have ternaries, Python doesn't have ternaries, right?
I don't know. I don't use Python. There's ways to do everything.
Yeah, I think Python, I might be thinking of a different language, but one of them doesn't have ternaries. So if you're coming from a language that doesn't have ternaries, just know that this is a one-line if statement. You've got your condition, your true condition, and your false condition. And what Timmer was saying is that people use this special $preview variable because there's two rendering modes. There's preview mode, which is very fast, but then the other one is called render mode. And like if you're trying to export this as an STL because you want to do a 3D print of your candle holder, you want to render that at a very high quality output. So you can do that conditionally to get a good trade-off between rendering performance and final quality there. So there's a lot of these special variables. I've never used these. System variables. Yeah, there you can draw a lot of parallels to. They are called system variables officially. Okay. So just be aware of them. The $children variable is kind of cool. If you're using React.js and you've ever seen props.children, it's very similar to that, where if you have a special transformation and you want to modify the children, but that's getting kind of advanced. I challenge you to look it up in the docs later. And then the other one I'm going to mention is these the ones that start with V. If you want to create it so that every time you open OpenSCAD, it's in a very particular camera angle, it is possible to configure that using the viewport translation, viewport camera distance, the camera view of field. It's useful. It's not something you're going to use every day, though. So just thought I'd mention it. All right, so moving along, we've got these things called modifier characters. So if you were a programmer and you were doing something like, foo equals bar, and then later on you decide, oh, I want to disable, my IntelliSense is getting in the way. And you say I want to disable this. As a programmer, you might do something like that, right? You just comment out a single line. In OpenSCAD, there are a lot of times where you're like, oh, I really want to highlight one object in this sketch, or I want to hide one object, or I only want to view this one particular object. There are symbols like that. So the pound symbol here will highlight an object in transparent pink. So if I'm looking at this code and I'm like, okay, there's a comment that says center stand, but man, I can't find it. What's going on here? So I'll put a pound symbol in front of it. And can everybody see that? Now the center stand is red. It's like a translucent pink color. That's really helpful if you have a very complex design and you're just kind of lost and don't know where stuff is. There's another one that's more advanced where, like, if you had something in your design but you don't want it to actually 3D print, you can use the percent symbol, and you can see there. Does everybody see the way that the center stand is kind of translucent now? Like, it's still part of this file, but it won't actually preview out. And I bet, I don't know if I should, whatever, I'll hit it. I bet if I hit render, it's going to disappear. I don't know that for sure because this is not one that I use a lot personally. Well, it's still rendering. Yeah, if you see the little huge mistake on my part to have a $FN of 50, I think I'm going to change that as soon as this finishes rendering. Yeah, that's my fault. I'm going to maybe just cut that in half and then re-render. Okay. So yeah, so it didn't, it's interesting that it kept it gray there. But yeah, so there's also that. And then you can disable an object. The other one that's really cool I like is the bang symbol, the exclamation point. If you're trying to focus on just one part of your design, you can put an exclamation point in front of it, and then all other parts of the design will disappear. So it's not something you're going to use all the time, but it's nice to have in your toolkit of things you can use, especially when your designs start getting more complex. So how's everything looking in the chat? Good. All right. So yeah. All right. So then this is really good for if you want to do stuff on Thingiverse. Like I saw Timmer a while back made a mold where he took a regular design and he encased it in a cube, and then he poured some silicone. I think that was you that did that, right? For like the wheels. Yeah, we had somebody make at the Makerspace make some rubber wheels. So we're going to learn a couple concepts here. First concept we're going to learn is this thing called import. So let's say you go to Thingiverse and I find this really cool rubber duck on Thingiverse and I want to modify it. So I'm going to take that and I'm going to, I'm going to go back to my test.scad one. And so there's a thing called import, and I got to reset my view here. Sorry, folks. Let me reset the camera. Okay. So, yeah, no surprises here. Ducky.stl is a nice rubber duck. But let's say, okay, I want to make a rubber duck soap bar, right? So I'm going to 3D print a mold for this. And so the way you can do that is we're going to create a cube, and we're going to put the duck inside the cube. And then, okay, so we're almost there. You can see I've got the cube, and the duck is definitely going to fit in that cube, but we need to do a translation now. So I'm going to move the rubber duck a little bit more towards the center of this design. Okay, so we got that there. And did I say soap? Actually, it's a chocolate mold because soap isn't going to work for the example I just gave you. And so the last thing we're going to do is we're going to subtract the rubber duck from the cube, and then off to the 3D printer we go. So let's go ahead and do that. So I'm going to do difference, and then I'm going to wrap that. And then as soon as I hit save, look at that. We've got a nice cube here with a rubber duck that we can pour some chocolate into. Hopefully it's food safe plastic. But yeah, so that goes to show you. It would also be useful if you're trying to make metal parts, if you do casting. So yeah, any questions about that so far? How are we looking on the channel, Paul? All right, cool. So yeah, import is very useful, as is difference. You can see how all of these primitives combine, and you can do some pretty cool stuff. So let's look at another example, and this one's coming straight out of the OpenSCAD examples folder. Let's say that we wanted to make a like Gutenberg style movable type printing press, and we need to create like 3,000 different letter blocks, right? Not something that's going to be easy to do with point and click. But yeah, if you go here, you go to examples, and then where was that one under? I noted, oh, it's under basics. So if we go under file, example, basics, and then we hit letter block, you can see here there's the letter M. And so I could do something here where I translate, let's do move it over 10. We're going to move it over 10 units. And then I'm going to do a letter block that has the letter R. And I'll save that. Oh, it's because it's not writable. So let me. All right, so I didn't move it over enough. But you can see the applicability here, where if you wanted to create 36 different blocks, it would be very easy to do. And we can talk here. This one's getting a little bit more advanced, where they're doing a custom module, which is similar to, but is not the same thing as a function. But you can see here they've added some parameters to it, so you can actually change the size. If we wanted to make it half the size, you could do that. And so this module, this is how a module would work, right? So yeah, so that's again that's a module where you want to reuse. If you have the same set of steps and you want to change like one thing, you would do this syntax here. You have the word module, you give the module a name, and just like a function declaration in JavaScript, I am hesitant to use the word function because there is something in OpenSCAD called functions that we're not going to learn in this class. But all of this stuff can be repeated here. Side note, you'll see that I have a function called echo, and that's similar to like a console.log statement in JavaScript, or a print statement in other languages there. And then, okay, so this one can get a little bit tricky. Looks like we've got some folks outside enjoying St. Patrick's Day. I think probably noise cancellation canceled that out. But yeah, we had some bagpipes earlier, and I guess there's quite a bit of laughter outside. Yeah, so let's talk about extrusion, because no CAD package would be useful without extrusion. I'm going to pop into the docs for this one, because this one can get a little bit tricky, and I actually haven't used OpenSCAD in a while. But, you can think of linear extrusion as the pasta maker. Like this one, it looks like somebody took the letter H and they linearly extruded it. So you're basically just taking a shape and you're pulling it in a line, like the name would suggest. On the flip side, you can also have rotate extrude, which is like a potter wheel. And that's really useful if you are making pipe fittings or anything that's round. And you can even, there's even been people that can do spiral shapes like this, where you're able to twist stuff. Yeah, railing is, we had Paul just brought up that having rails is pretty useful. So that's linear extrude, and we can see that right here. So let's do linear extrude first, and then we'll up the complexity a little bit with a rotational extrusion. So first, step one, we're going to have a circle, right? I'm going to reset my view. Reset view. I wish there was a hotkey, but I'm not aware of one. So we've got the circle, and then now what we're going to do is we're going to move it over 40 units. Okay, so we got that. And then lastly, we're going to apply the linear extrude there. And yeah, I believe you can change the height of it. Yep. So if it does have a default value, which is probably not useful ever, unless you're teaching a class. But you can set the height that you want to extrude here. We could try something like, anybody remember off the top of their head? It's text. Yeah. So we can linear extrude wow, and now we have some like Microsoft Word 1997 word art over here. So that's a linear extrude, but now let's kick the complexity up a little bit, and let's just change it from linear extrude. Let's change that word to rotate. Oh, it didn't like that actually. Hold on, I made a. Oh, okay. It's because it has different parameters. But this looks like one of those toys that they give dogs to for feeding them, like those feeding toys. But this is actually the word "wow" spun in a circle. Can everybody see that? Okay. If we comment out the word linear extrude, you'll see it's just the text from earlier. But we essentially spun it. And this part can get a little bit tricky. I like going to the docs. They explain to you how to do a rotate extrude. They have something called the right hand grip rule. It takes a little bit to memorize this stuff, but just you can always think about that one. And yeah, you can set the angle, and then the convexity I'm actually not sure about, but we should be able to. I've only ever had to do circular rotation, so I'm curious. Oh, this is getting even more advanced. Let's see if we can try that the angle one. Let's try doing like 45. It generated an error. Anyone know why this is? Timmer, have you used rotate extrude recently? Oh no, I think it's a named parameter rather than a. There we go. Okay, so yeah, you have to explicitly name the parameter. Doing this syntax you see here, where you do angle equals 45. Yeah. So, this one, it's interesting. It's the puffy outline stamp is the worst possible description I can give you. So imagine you've got a cube, okay, and then imagine you've got some other shape, and you want to like spin it around Roomba style, so that like if you had a cube with hard edges, you wanted to give it spherical edges. This is going to make a lot more sense if I just show you. So I'm going to comment out the transformation. Okay, and so now you can see here all I've got a cube and I've got a cylinder. Not very interesting so far, right? But now I'm going to add these to the inside of a Minkowski transform, and we are going to see like this Roomba. It's going to like basically take this cylinder and rotate it all along the edges of the shape. And what we're going to end up with is a rounder cube. And let me up the $FN. Let me set that to like 20. so it gets a little smoother. So this is really useful when you're making like cases and stuff, and you want round edges. There's probably a better explanation on it, but it's one of the more advanced ones that I think you'll find pretty useful.
Rounding the edges like that is the hardest thing to do in TinkerCAD.
Oh, is it? Yeah, somebody just mentioned that in Tinkercad they've had some challenges rounding the edges. So yeah, this makes it pretty easy. It can get a little tricky when you're dealing with precise widths because you have to account for the shape that's actually being applied as the second argument. You have to take that into consideration. But it's nice. It takes two objects generally. Any questions coming in from YouTube?
We have a comment from Ivor.
Okay, I've just been notified that ducky.stl is actually a mallard.
And do we have 2D lines that we can turn into a solid object here?
Like a path extrusion. So I believe currently, Timmer or anybody in the chat section, I don't believe that OpenSCAD yet has a path extrude. So like if we look at this one, let me just copy paste this one that let's take a look at what they did in the docs here. Let's just explore this. Yeah, so this one is actually, you've got a linear extrude here. Gail, is my mouse pointer visible?
Yes.
Okay, just making sure. And then there's a second rotate extrude. Then there's a third rotate extrude, I believe. Let's see here. So there's one rotate extrude, two rotate extrudes, and then there's just a traditional rotate, which we haven't learned yet. But yeah, I'm a little disappointed that OpenSCAD doesn't have it. I believe there's some technical reason why it doesn't support it yet. But I do wish that you could take do like an array of three-dimensional points and like have it follow that path. I am not aware of a way to do that. If anybody,
I'm not seeing 2D lines at all, which is not bad. I mean, it's stipulating a surface with a 2D outline.
yeah, so what Paul just brought up is that he's not seeing any 2D anything in this one, and that's, I believe, correct. Yeah, it's just doing a, and I wonder what this EP. Oh yeah, you're right though. Those are circles. I wonder what this EPS parameter does. Let me set it to like. It is not earnings per share. No. Yeah. So yeah, that's one thing I wish it would be improved. You can do other things like is this more what you were thinking about, Paul, in regards to two-dimensional? Yeah, so this one's a rotate extrude. That one you can do where you take a polygon like this. We haven't learned the polygon one in this class, so don't feel lost if you haven't seen that before. But you can enter basically a two-dimensional array of points and create this two-dimensional design, and then you can spin it like they do in the docs. So that's very useful for a lot of mechanical designs. But yeah, still no path extrude that I am aware of. But if anybody, I believe there's third-party libraries that you can download and add to your project that makes it possible. But yeah, none natively that I'm aware of. And then let's go back to our mallard. And I want to show you guys something interesting here. So we've got our mallard, and we've mentioned rotate, but I haven't really. Let me reset my view. Man, I wish there was a hotkey for resetting the view. So we've got our mallard here, and then rotate, true to its name, rotates it 90 degrees on the y-axis. And that's really cool. But let's say like those children's toys, square hole, square peg kind of thing. Let's say I wanted to make one for this duck, and then I want to go upstairs and I want to take that DXF and I want to cut a mallard-shaped hole in a piece of plexiglass. You can do that using this transformation called projection. So we're going to go here. And so now it's 2-dimensional. It looks 3-dimensional, but I promise you it's 2-dimensional, and we can turn that into a DXF, take it upstairs on a thumb drive, and then cut a hole like that on the laser cutter. So very useful for a very specific type of project. Any questions so far? I know it's really cool, isn't it? I wanna like do a bunch of these and like have like a mallard mesh piece of plexiglass for I don't know what. Yeah, so you'd go here. The question was, have you tried the DXF function? And I have, not for this particular design. I was doing a motor mount plate many years ago, and I just go here. I think it's going to complain because I have to render first. So let's see how the DXF. All right, we're getting pretty close. Doesn't seem to care. Seems maybe the question was somebody was unsure. Does anybody know of a good DXF viewer online that's not spam? Maybe we're not going to be able to double Inkscape. Okay, I'm going to try. So the question was, is OpenSCAD's DXF renderer actually any good? Okay, I guess I've. Okay, let me try opening one here. Yeah, I could. Yeah, somebody just mentioned that path extrusion is a 12-year-old feature request. I could see that. I'm sure there's a good reason, because such a. All right, so. Okay, I'm having issues opening the Ducky DXF file, but that's probably because I've never used Inkscape on this computer before. I think it's going to work, Paul. I'm telling you, I've done it. I've laser cut plexiglass. But yeah, so you got that. Yeah, 2D to 3D projection, very useful for our laser cut. And I just, look at that, Paul. The next thing was how do you export a DXF? And we already saw how to do that. And then so another question is, okay, like I want to 3D print that duck. Like this would not be a very creative design to just have an OpenSCAD thing that's just an STL import and then immediately export it. But you can do that. You would just go to File, Export, and then you would do Export STL file there. Apparently, it's so popular that they use the F7 key. And then once you have that, you put it on your thumb drive. You go upstairs. You put it into Slicer. But this is not a Slicer class. Maybe we can teach that. We've got a question.
What happens when you hit the export? Does it generate code?
When you hit File, Export is STL. It just generates a STL file.
Yeah, it turns the rendered object into STL.
Oh, okay, but it's not generating.
It has to
A
be
macro.
generated.
Yeah, no, it's not generating a macro. No. Yeah, it'll be a pretty beefy STL file. So good question there. Yeah, so then when you do have your STL, and this would be the topic for another class, but this is a question that people at the Makerspace ask a lot is like, okay, I've got a design. You're going to want to slice it and turn it into something called G-code, and then the 3D printer will be able to print your design. Maybe that's one for next month. So yeah, a couple things. This is actually from the old class. I don't remember. Timmer, do you remember we had some setting recommendations last year when we taught this class? Okay, the only one that I don't like is that it has a really bright color scheme. So I like this is what it comes with by default is this yellow, and there's a lot of different color schemes. The one other thing that I like, do we have Octoprint still?
Yeah.
So yeah, so if you're at the makerspace and you're on our Wi-Fi, you could potentially put the Octopi. Oh, okay. Well, I guess yeah. Just somebody's just informed me we don't have our slicer set up, so that's too bad. But there, it is possible if you do have an Octopi server running on your LAN, you can send your design straight to your 3D printer. There was one other one. Oh, look, Paul, there's your question. Default to ASCII STL export, because I think the default is it's going to be the binary STL format. All right, so yeah, we got that, and then yeah, we're just wrapping up now, but there's a couple third-party libraries that I think are really worth looking at. Like there's one called MCAD, because you really don't want to reinvent the wheel. There's been a lot of community involvement within the OpenSCAD community, and so for things like screws, oh, they don't have any cool screenshots. Let me Bosl, BOSL. I might be pronouncing it wrong. That one has some pretty good stuff. Like, and I believe they do linear extrusion. Like, I'm pretty sure. I guess I won't bore us by looking through the documentation here, but I believe one of these libraries does have something where, like, at the application layer, you can do some pretty cool transformations beyond the basics. You can see here staggered spheroid or a teardrop 2D, those kind of things. These are all things that OpenSCAD doesn't do natively, but other developers have come in and, you know, extended the functionality through third-party libraries. Yeah, and then there's a couple things I didn't cover that, you know, as a homework assignment for you. These things you see here. Scale is very useful, going back to our Mallard. If you wanted to make it 3x bigger than what it comes with, that's how you would use it. The use statement is used for a lot of these third-party modules. But yeah, that's basically us. You know, how to use OpenSCAD. Come see me if you're local to St. Charles and you're a member at the Makerspace. Come see me if you have any questions. And sorry for the little hiccup we had earlier. It's too bad because we're not going to be able to reshare this video because the first half got clipped off. But yeah, thanks everybody. And oh yeah, actually, any questions there? No, looks like we got no more questions. So cool. Yeah, thanks for stopping by, everybody, and I'll see you later.